the assessment is different. The GSVs is kind of a crude tool for measurements in boreholes and equating them with potential surface fluxes. But it does assume shallow boreholes and relatively shallow response zones. So high-risk scenarios, deep, large volumes of gas in reservoirs and migration up open conduits needs a different kind of assessment. So if you need to do this kind of assessment, when and how should you do that? You don't need to do it all of the time. You can do a simple preliminary screening assessment and show that a site is negligible or very low risk. And if that's a confident assessment, either purely based on the desk-based information or backed up by site investigation, that's a perfect and fine place to start to end even. But if that preliminary assessment is highlighting some moderate or high risk factors, then you might need to consider other things. But if we're saying when you don't need to do gas flux calculations here, so your preliminary assessment is moderate or high risk, but then you've got site investigation data that shows that, okay, maybe I might have some moderate or high risk factors. However, groundwater levels are fully saturating the workings and they're there all of the time, and I'm confident in that. And we've got a consistent covering of glacial till. Or yes, there's a mine shaft nearby, but look, I've had a look at it and it's confident it's fully grouted, or it will be grouted, or it is vented and maintained. Then, although you've got the high risk factors, you've got sufficient lines of evidence there and confidence to allow you to move back up the risk assessment model and confirm a low risk. Or potentially you've got some moderate factors. I wouldn't say necessarily high risk factors, but you've got some moderate factors, but you've done a really robust scheme of ground gas monitoring, probably continuous methods are definitely capturing worst case conditions and the drivers for gas flux at your site. So if you have variable water table, you've captured that within your monitoring period. If rainfall is a driver for gas flux, you've captured that, or if it's the classic atmospheric pressure drops. And then if you've got that data set, which is robustly targeted to where the ground gas source is or intercepting the pathway, and that shows CS1, then you can stop there. So when you will need to use the gas flux calculations, is like I said, your preliminary assessment is moderate or high risk, and those high risk factors remain, and you need to assess them specifically and have a think about gas flux up a shaft, or for instance, or gas accumulating under a building and ingressing. So shallow unflooded mine workings, mine shafts or adits on site or very close, or open fractured fault zones. So it's all about preferential pathways, really. I think that's the key thing that makes mine gas different and higher risk and needs to be assessed. So how would we do that? There are different simple one-dimensional steady-state equations that we can use for gas flux, and modifying some of the assumptions in the models to make them specific to your site in terms of the migration distance, and the type of soil that the gas has to travel through, or the permeability of the pathway. It's possible to do a kind of a calc and a model. Keep in mind, these are very simplistic, like I said, one-dimensional steady-state equations. Those conditions don't exist in nature. So these models are inherently wrong. So why would we do them then? They're useful. You can make some conservative assumptions, and you can show, look, even if this unlikely scenario is happening, my design is robust enough to deal with it, and it gives you a level of confidence that your assessment is suitably precautionary. Definitely need to be done carefully, maybe with a sensitivity analysis on different input parameters, so you capture all of the uncertainty that you've got. And also maybe modelling multiple different scenarios. Is it gas accumulating in a nearby in the subsurface very close to the inside of the property and being pulled in by the stack effect of the building through the floor slab? Is that the key pathway that's going to drive the risk? Or is it a significant pressure drop causing a reservoir of gas that's at depth in the ground to get pulled up a shaft or a preferential pathway? Maybe it's worth modelling both of those and seeing which one comes out as the higher risk. That's definitely what we do when we do these kind of equations. I'm going to touch very quickly on gas protection design because I think it's important. Often the calculations are done at that kind of stage to justify a ventilation design, for instance, or justify a specification of a specific membrane that's going to be used in a design. Design, especially when you're not following BS 485 with a generic screening approach, is obviously more than adding up the points in the guidance. It needs to be thought through, specific to the site, done by somebody that really understands the ground gas risks and conceptual model on the site, and should include all of these things. Gas protection design is made up of generally three things: structural barrier, some kind of membrane, and ventilation, combination of those things, normally two of them, sometimes in high risk scenarios, all three. And for coal mine gas protection design, the two most common solutions for most sites are a combination of some kind of subslab venting and a membrane over a suspended floor, or a raft foundation that offers really good inherent protection itself and a membrane. Generally with rafts, we put the membrane underneath the raft so it's out of harm's way and not going to get damaged by follow-on trades, but that's a kind of designer specific assessment. And seal the utilities ducts, very important. We know this is important because we've measured carbon dioxide coming from mine workings inside people's properties that were built on a raft foundation. And the way that it was coming up was through the utilities duct around the water pipe. It's the first place we look when we've got gas inside a home. And often sealing that up is the way to solve the problem, especially if you've got a raft foundation, which has really good attenuation on its own. So that's a little example. The graph shows it there where we're monitoring carbon dioxide inside a property getting up to quite high levels. And then after sealing the utilities duct, it's gone. So it's really important that's included in designs. I've mentioned drill and grouting already. It's just some things to consider when we're reviewing drill and grout specs or inputting to them there. One key thing, I've heard mention of sacrificial plastic casings being used for grout holes. I've not measured on top of one and justified this and proven it, but in my head that could create a vertical conduit, increasing the permeability of the shallow ground and allowing gases to migrate. So I would always want to see a drill and grout spec confirm that casings were going to be removed from grout holes and that they would be grouted all the way up to the surface. We've done a few detailed assessments of the risk of drilling and grouting actually pushing gas onto adjacent properties, and in some situations recommended that the grouting is done at the site boundary and working into the site rather than working across the site and pushing the gas out. And that is often kind of all that's really needed to deal with that as the potential risk. So in conclusion, the approach to risk assessment and design is based on the risk profile. If you're negligible or low risk, then you're fine to do a screening assessment. Maybe you'll gather some gas monitoring data just to make that assessment more robust, but it needs to be conceptually low in order for that to be applicable, and obviously all the monitoring results be sufficiently low as well. If you're getting to moderate to high risk, can you use your site investigation to show that actually the risk is low if workings are completely flooded or the shaft's appropriately treated, for instance? Or do you need to do some gas flux calculations to inform the design if those high risk factors are still present? And they need to be modelled in a different way than a generic screening approach from borehole data. Great. And there's more training available on this topic via Claire. And we'll take questions later on. Yeah.
That's great. Thanks, Amy. I've got to admit I wasn't actually aware of that Syria document somehow. And being in a my legacy city, it's a bit embarrassing. I wasn't aware of it. And the flow chart looks incredibly useful, just as just a very rudimentary decision making thing. So I'm going to deep dive into that at some point very soon. So thank you, Amy. Well, yeah, we'll pick up questions later. Okay, moving on. Our second presentation, titled Mine Gases, Case Study Examples and Verification Considerations, is by John Naylor, the Technical Director at Ground Gas Solutions, and Neil Salvidge, the Training Manager, Training, Development and Assessment. John has over 20 years professional experience working within the contaminated land and landfill arenas for both public and private sectors. He has worked to improve contaminated land investigation, assessment, remediation and verification at both consultant and regulatory posts. Neil has assessor status with CITB and the initial assessor for NVQ Level 2 in ground gas membrane installation. He is involved with developing industry standards and has supported the development of NVQ Level 4 and verification of ground gas systems. John and Neil, over to you.
Morning. Yeah, good morning. Thank you very much. So great start talk this morning from Amy, which actually saves me a lot of my voice because she's covered pretty much a lot of the things you need to watch out for. But actually this works quite well because we're going to go through a case study of the Gorebridge that covers pretty much a lot of the things Amy was highlighted. So we'll see how that fits in. So I'm just going to share our presentation screen now. So hopefully you can see that.
Got that, yeah. Thanks, John.
Fantastic. So we're going to go ahead and talk about the Gorebridge mines gas incident, and then look in with Neil about the verification. So without further ado, let's get the screen going. So first off, I'm going to talk you through the Gorebridge mines gas incident. So I'm pretty confident most of you have heard of this one. And there's an actual picture of the housing that was involved. So the first question is was there a ground gas risk incident? Well, there was, but was there a risk? Amy's already told you where to go and find that, but just going on, the internet, you can get all kinds of stuff on, and here's some historical maps that show 1907 that actually show the location of the Gorebridge housing. So the green line is where the estate was built, and already within there you can see shafts around there. So it's not unusual, or shouldn't have been unusual, to expect a problem. Most of what we're going to talk about in the next sort of 6 or 7 minutes is actually what was in the NHS Lothian Incident Management Team report, which you can get hold of and have a read through at your own leisure. It's over 100 pages. It's got a lot of appendices in there. So if you really want to see what happened and how it happened, or how it unfolded, at least in the eyes of the NHS and the Incident Management Team, grab a copy of this. But essentially, what it showed, and I'm going to go through highlights, is that a death study was done and did, funnily enough, identify mines gas, and a site investigation, a risk assessment, did some monitoring. Well, I say risk assessment, the monitoring was done, but they didn't find anything too bad. And then they basically said that no gas protection measures were required. Now, I've already heard earlier why that might not be a good idea when it comes to mines gas. 2009 comes, 64 homes built. 2013. We had our first residents taken to A&E. So, there's a good 4 or 5 year period there between the houses being built, occupation, before we actually had any reported incidents going on. And it was not until April that the IMT was set up, once it was established there was something a bit more going on here. By September of 2014, 22 people had attended A&E or the local GP to seek advice or help. And through further monitoring, elevated CO2 had been, or carbon dioxide had been confirmed within some of those properties. The decision, rightly or wrongly, was made by Midlothian Council March 26, well, probably before March 2016, but all those houses were demolished. That was the solution at the time. And of course, don't forget, it's not just the housing that's being demolished, we're displacing families. So, you know, a very critical case study to bring up today. So let's run through a little bit of commentary that we've picked up in the IMT. So not all the SI records were actually identified and found. Okay, we've already gone through what the death study found and what the SI boreholes found. But was there a high risk potential for mines gas? Bear in mind what was said earlier. Okay, the gas monitoring unfortunately hadn't been carried out in opportune periods. Had it been, it probably would have seen a different story. And unfortunately, that hasn't been best practice since the 1990s. So again, unfortunately, they're here. CS1 was classified by the consultants, and we've already heard about, is that, well, actually using GSVs is the right thing to do on some of these sites, and therefore concluded nothing special required. Well, for me, the monitoring results that we've found and the conclusions are completely at odds with what we found in our risk assessment. So, bit of a red flag for me there. So let's look at some of the aerial photography just to see how it developed. So it's back in 1945, so just some fields. And we moved to 2003. Now, what's interesting here is that the strip where the housing was built was all grassed, open space. Okay, don't know why, but that's how it was. Okay, and then 2009, here you can see all the new houses nicely built and occupied. 2012, it's still there. And then by 2016, the evidence is in Google Maps of all that demolition. So it's quite a sizable area that they've actually taken out. Okay, and that remained the case until relatively recently. And it's only since last year that they've now started to redevelop Gorebridge or New Byers Crescent. So let's take a little look at what might have gone wrong in there. And already mentioned earlier is about grouting, and it's really important. I can't stress how important this needs to be in your risk assessment and plans when it comes to remediating and fixing coal gas affected sites. So here we've got a grout take plan of what they did, and where that red circle is there is actually where the two houses were first identified with elevated gas. And as you can see through the sort of expanded view there, you know, there's quite a lot of grout holes in there, but was there enough? And you can look at the takes there are very different. So from some places less than a ton to others greater than 10 tons. And again, you know, that's usually an indicator of pillar and stall methods of mining. So it's where they've hit a pillar of coal or they haven't. Should they have gone in and done closer, you know, even at more than 3.5 metre spacings where they've got greater than 10 tons, just to make sure that all that's been filled in. Within the IMT, we've got some report conclusions. In there's a conceptual site model in a schematic form. Credits to Fairhurst for that one. Okay, and it just says everything that we've seen. The source was confirmed. Workings were found not to be fully grouted. Grout holes possibly not sealed, but obviously the evidence is gone because it's all been built on and covered over. SIs possibly not sealed. Boreholes. Stone column foundations, possible pathway, and of course, service entries weren't sealed because there was no requirement for gas protection. And as we saw earlier as well, the highest CO2 was associated with falling atmospheric pressure. Just to give you an idea of grouting, so that photograph on the left isn't Gorebridge, but is not unusual to be seen on some of these grout jobs. This is the sort of plastic tubes that they sacrifice and put in there, and they fill those with grouts. Remember, the idea behind this is for geotechnical purposes. So they just want to make sure the ground doesn't collapse. They're not necessarily thinking about any pathways they're creating to the surface. This particular photograph was taken once the grouting had been apparently completed, okay, and left like that. And, you know, all I needed to do was lower a dip tape down there and find that there was a complete pathway straight from where the shallow mines were straight to the surface, and there'd be several of those. Okay, so all of this is back to the Gorebridge IMS. Workings beneath the site. They've done better? Of course, stone columns, could they have creased that problem or gone through the drift that was on site? Got a ground bearing raft, not a problem with that. It's fairly common up in Scotland. Should a pressure relief layer been put in? Could that have helped? We know those weren't, because a decision was taken by whom and when that it wasn't required. So this is the IMS. My question really is, should this have been entirely preventable? Okay, let's have a look actually now at one of the houses. So we're going to focus on 87 new buyers, and we're just going to go through some of the concentrations found within the property. Okay, so this is percent by volume carbon dioxide. And as you can see, those figures aren't getting any smaller. Okay, so quite significant and serious amounts of CO2. And a borehole that was drilled into the seam at 13 meters found pretty much the same kind of concentrations of CO2. So straight up through and into those properties. And no grout, funnily enough, was found in the coal seam at that location. So again, it's proving the point. Some continuous ground gas monitoring was done at that location by the Coal Authority, now the Mining Remediation Authority. And as you can see there, here they've used red for carbon dioxide, and you can see that's peaking at 25% quite on a number of occasions. And for those eagle-eyed and monitor, you will notice that it's when atmospheric pressure falls, and indeed here is then the actual A&E cases start to happen as a result of quite a massive pressure drop during that day. So there's the evidence, and that's what's happened. But let's have a quick look at carbon dioxide and its health levels. So just to give you guys an idea of what we're worried about. So 1% you might be feeling tired, 2% headaches, 5% dizzy, all this kind of stuff. 8%, it's not looking good. 10% vomiting, and then at 25%, you're lucky to be, well, you won't be walking around if you're exposed to that for too long. HSE, or rather the occupational exposure levels, have been set for workplaces, by the way, not residential settings, as a short-term and long-term exposure. When we look at the results from Gorebridge to that property, you'll see that, you know, we're way over where we should be, and quite dangerous. But what about low levels of health risk from carbon dioxide? The jury, it must be said, is still out. There's quite a number of papers out there. I particularly like this particular diagram taken from a paper from the US in 2012, where they did several different kinds of sort of tests on CO2 exposure at different levels, 600 ppm, so probably, you know, fairly normal stuff. You could even argue maybe 1,000 ppm is probably acceptable generally inside air, but over 2,500 it's getting a bit elevated, and you can see here the effects on different activities for different things. Interestingly, not all of them are as affected at higher levels. Some others clearly are. So what does that mean? Well, 2022, DEFRA Indoor Exports Group came up with some recommendations, and essentially they said anything more than 1,500 ppm represents poor indoor air quality. It didn't go as far as saying it was a health effect. And then in a year earlier, we had the IAQM come up with actually over 1,000 ppm. You really need to be thinking about it. So there's just some things, some food for thought there when it comes to regulation and what levels might be looking at when it comes to doing something about it. So that's the gore bridge. And now quickly over to Neil.
Thanks, John. Well, that's interesting seeing those findings. And when I spoke to John about presenting this today, we thought we'd bring in some of the elements. Those that have met me previously on ground gas training, we talk about the verification and how much difference would it be if verification existed today for gore bridge. So I just kind of used some of the slides that I've previously used, but using also the Series 735 decision structure, professional judgment, looking at all the site investigation that Amy and John have both gone through. Should the verifiers be factoring this into their verification reports and their working? So as I witness a lot of verifiers on site, if I was to mention this to them, well, it's been done, that's finished. So I'm sometimes a little bit concerned about how much verification does take place of the site summary. And just looking at that, assuming a CS1 situation, should they just rest on their laurels at this point and that's verified, move on? Or should there be more robust verification happening at this point to justify what's been done in the remediation, especially grouting that I picked up on there, John? Do verifiers come and check the grouting? Yeah. So also, we're looking at the competencies of people doing this, both verifier and installers. So if design systems are implemented, the decision structure rates where we should be looking, are they going to be high risk installers? Doesn't risk the verifier because hopefully they're going to be competent. But certainly demonstrating the competencies that are there today. We have got the MVQs for our installers, came out in 2010. We have other qualifications for the MVQs for verifiers and also the CLARE SGPVs and TGVPs. Again, these weren't in existence at the time of Gorebridge, so not particularly any use at that point. It was being drafted in 2014. But also having acceptable methods of both installation and verification practices should be demonstrated in the verification planning of what's going to be done. So just thought we'd include that there. Again, design, Amy touched on a little bit about design. 735 talks about the designer being competent, understanding the different elements and what tools they've got in their bag to use, what guidance. Now, British Standard 8485, whether appropriate or not to the gas screening values that have been highlighted here, but in 2007 was its first issue of 8485. So there was things out there telling them about design of gas protection systems. Other documents exist, some of them may be relevant, especially though we've got 748, which is the VOC barrier, not particularly relevant in this case, but verifiers should have understanding of all these codes of practice to use them. And the other one that we highlight is the qualified experience and suitably trained to do this. We meet a lot of people now that say they're designers, but they're just working off standard details. Cut and paste, that'd do. I'm sure the manufacturers or the supplier of those standard details do not take the consequence and the professional indemnity for providing them as the final detail. So something that I'm always wary of when I'm questioning verifiers. Also, the inspection and testing regime. Are the verifiers? Well, there was very little inspection carried out when Gorebridge was built. I've just listed some of the modern methods that are quoted in 735 there. I think visual inspection would have been really the only option used there. British Standard 8485 2007 did mention about carrying out CQA, construction quality assurance. So was records kept of any of the work that was done? Well, it wasn't specific to gas protection. So hopefully the site manager would be doing regular inspection, periodic visits of key stages of works anyway. But I just thought I would include there the current 735 main checking points or checking methods that are available to us to use. Yeah. So defining those contents of the final verification report, be mindful here. Is it going to contain good or is it going to contain bad outcomes? Now, John's chuckling at me. Have you ever sent a report in with bad outcomes, John?
Oh, yes.
Well, so don't just assume that the report's going to land and it's all going to be singing and dancing and signing the job off. There could be some bad news in there that people along the line have not picked up on, or it's not been actioned. You know, work moves on a pace on these construction sites. So being mindful of that. We also use, and I use this a lot in my assessment practice, VAR. So it's nothing to do with the professional championship, Premier League football. It's valid, authentic and reliable evidence. You know, if we are going to produce it, certainly if we're going to rely on CQA from the installers or third parties that are involved, is that going to be valid, authentic and reliable? Has anybody ever cut and pasted anything that you've seen in a report, John?
Certainly have. It's happened a number of times.
And Google's a wonderful tool to find some of this information. I've seen pictures of my own work being used on other people's projects. So just buyer beware, but also recording any non-conformances and making sure it's carried out and instigated and corrected. You know, it's part of the verification process. Yeah. So going back to our prerequisites, we've done a lot of work there, and hopefully these are going to be kind of checkpoints that we'll see. But there's a slight fly in the ointment that came around in 2022, and I'm going to bring it in now where we talk about the Building Safety Act. It's been a massive game changer. It's going to put a lot more onus on competencies of everybody. There's nobody exempt from this, where you sit in the framework. And I hopefully will highlight that in the next slide when we talk about the key stakeholders that are involved in what we do. And the golden thread. Now, if you've not heard of the golden thread, it's very worthwhile looking into it, because it's where all these stakeholders have a duty, and even the regulators sitting there at the kind of figureheads and pressing the buttons, yes or no. But that golden thread is going to loop, change, turn around. And we know this has come around from off the back of the unfortunate events in Grenfell Tower. So hence, keeping accountable trails of who's made decisions, what's been done, verification, it's all very important. So just to kind of wrap up, would Gorebridge happen today? Well, there's lots of things, hopefully better site investigation, more thorough record. I think, you know, what was done at Gorebridge, hindsight is a marvellous science.
Sure.
Good design, appropriate SI to build that design, appropriate people. I've listed there, again, build and designed. Cost always plays out. If somebody can do it a bit cheaper, are they cutting corners or are they doing it for the good of the project? You know, compromises are often made there. Compliance to standards, hopefully quality workmanship. I've been badgering on about this for about 15, 20 years now, is improving. You know, and that final reporting, evidence of this, good verification, it's really important, and hopefully it's going to get better and better, because you don't want to end up here, that person with the curly wig asking some very awkward questions. That is what the Building Safety Act is going to drive us to, or will result in, and we've seen the first litigation going through using the Building Safety Act, not in the ground gas sector, but it's only a case of time. So I just thought I'd finish off with a nice little side of hopefully Gorebridge and a little bit of work going on there. Have we got, this is Gorebridge today. Hopefully if we can play it. Can you get it here, John? We're just going to play you a little clip just so we can see that's the gas protection being installed in Gorebridge and some verification happening. And this was pretty much where you targeted them, the grouting, John, in that location. So that is Gorebridge today, and it's moving on in the right direction. So thanks, guys, for listening, and we'll meet you at the panel at the end for our discussions. Thank you.
Thank you.
Thank you. Thanks, John. Thanks, Neil. We are bang on schedule. That's great. So we'll now move on to our third presentation of this session, which is titled The NHBC and Ground Gas, which is by Matt Lennard, who is the Principal Geoenvironmental Engineer at the NHBC. Matt is a chartered geologist and SOBRE accredited risk assessor with 25 years experience in the contaminated land industry, where he's worked for consultants, contractors and landowners before joining the NHBC in 2016. Matt, thank you, and over to you.
Thanks, Anthony. Right, I'll share my screen. Hopefully everyone can see that.
Yeah, I've got that. Thanks, Matt.
Excellent. Right. So firstly, my name is Matt Lennard. This presentation is going to be going against the grain from the rest of the presentation this morning, where everyone's talking about coal mine gas risk assessment. I'm going to be more talking about just general ground gas issues, but I have shoehorned a bit of coal mining stuff in. So anyway, I've got a lot of slides to get through and not too much time. So let's just see if here we go. So firstly, apologies. Our corporate people have said we've got to have this disclaimer. I'll let you all read that. But to be honest with you, there aren't any dimensions or any details in my presentation. So hopefully it's all taken as read. It's not basically, this is not design advice. And my aim today is to run through NHBC's requirements for ground gas risk assessment and the design and verification and protection measures, and what we do see versus what we actually would like to see. I'd say it's actually a good thing. I'm not talking about coal mining gas risk assessment, because Amy John and Neil have already covered everything I'd want to say. So NHBC, we are the National House Building Council, for those of you who don't know, and we currently provide warranty between 70 and 80% of new build houses. So that's quite a bit. And currently we see on average, I think it's about 1 in 8 sites ends up having gas protection measures installed, which seems quite high to me. So, and for when we provide warranty for new builds, all homes registered must comply with our standards. As linked to standards, and for land quality and other aspects of the build, we set mandatory conditions to make sure that we're happy that the site is being properly assessed, where issues have been found, where gas protection measures are required, the measures are designed and installed correctly. And ultimately, if the mandatory conditions remain, the builder can't get a warranty, and with no warranty, ultimately there's no sale. So we're all pushing to get to that end point where everything's good to go. Quick reminder, I've spoken about Gorbridge already this morning. At Losco was the other site. So ground gas incidents, serious ones in the UK, rare, but they do happen. But often they're on high gas generation potential. In Losco, clearly it was a landfill gas with some nice pathways, and Gorbridge has been discussed already. It was associated with coal mining. NF94 was published back in 2023, nearly 2 years ago now. Great work from Amy and the guys at EPG and 1 or 2 others, including Neil as well. That can be downloaded for free from our foundation. And just as a quick headline, the old traffic lights guidance from 2007 is being withdrawn. And as of the 1st of July this year, we will no longer be supporting it or accepting risk assessments based on it. So, what the purposes for NF94, we see a lot of poor quality gas risk assessments, often very precautionary, often over precautionary, which is not to say we don't want things to be precautionary, but they can just take things to the nth degree. We're seeing more and more complicated builds with modern methods of construction and timber frames, and that's creating difficulty. And ultimately, we also see because we're an insurance company, from claims point of view, we get moisture ingress issues just along the horizontal, where a membrane's been installed horizontally across the cavity. It can act as a pathway. It's not normally, the membrane's doing a great job protecting from gas, but it creates a nice horizontal pathway for moisture to get into the building, and that causes us claims. And obviously, as an insurance company, we kind of clearly want to avoid that. The moisture ingress issue is often from poor workmanship, a lack of sealing in the cavity tray, or poor installation of the cavity tray is normally the root cause of that. But I think we see the biggest amount of claims we see in the NHBC from moisture ingress, and horizontal membranes are a problem for us. So anyway, so back onto your gas risk assessment, we see a lot of precautionary stuff. This is a photo I took the other week on my dog walk. It's a field. It used to have sugar beet in it, but now it's been ploughed up. But there's a bit of made ground there. You see where I was standing, it was on a track. So there's some stuff there. But is there really a gas risk assessment, or could that site be screened out? Is there really a gas risk, or could that site be screened out early on in the risk study stage? So at preliminary risk assessment, what do we see? Well, we want to see an initial concept site model. We want plausible gas contamination linkages. Are they present? Are the sort of gas sources credible? What about the age, the size? How much gas is going to be generated? And again, are those migration pathways, are they really plausible? Are they really there? Is there an offsite pond that was filled in 1900? Is there any gas coming from that? Is it really going to migrate 200 metres horizontally and pop into someone's house? So, and again, it's no different to doing coal risk assessments. And what we very rarely see is cross-sectional CSMs to scale. What are the geology, what the topography, what the depth? Just as Amy said earlier about, especially on coal mining, it's so important that there was an understanding of that when you did understanding and developing your risk assessment model. And development plans, it's great in the SI when it's a field, but what's it going to look like when it's being built and the houses are there, or whatever buildings you're building? What are the final levels are? Is that things being raised? All that needs to be taken into account. So this is what we often see in a typical gas risk assessment or conceptual site model. We see elevated CO2 from a landfill, migration through soils, and we get the consequences. And if you read the guidance, consequences we know from Gorbridge and Losco, consequences can be severe. So it depends on how low your probability is. If you follow that guidance in this one of the old CIVI documents, you'll end up with a moderate risk, which says you must do some do something basically. So that's all. That table's all taken from your all your site desk study, your site history, your historic maps, everything else. It's just been that diluted, condensed down to one line. But what happens if you do a cross section? So here's the geology. This is the site. This is the same site as that risk assessment. So it was historically it was a clay mudstone. They built brickworks in the 1950s, and then there was a big council tip in the 1960s to 80s. Then sometime in 1987, they built a supermarket on top of it. This kind of tied in with a Losco, and then so at some stage, not too long after that, they put some gas management system. And if you go to that site now, the supermarket's still there. You can see the vents and the cows in the car park. And then 2020, they neighbouring site, 100 metres away at the nearest point, they started building new housing development. It's a big sort of it's a massive site. There's a sort of hundreds of houses, probably about 1,000, and they did this, and they basically, based on the original that table, they put in some gas boreholes on site, found low levels of carbon dioxide, about 6-7%, and so every single house on that site has now got gas protection going in. Now maybe it's needed, but obviously, the risk drive for that was the landfill, not the clean cover. So the question should be asking: is there really a plausible risk? How's that gas going to get from the landfill across to the housing through that clay and mudstone? So maybe a more appropriate method of investigation there would be to investigate the potential pathways between the two. So what do we see? On-site investigation design should be based on the CSM, and always if you're out on site, have that conceptual site model in the back of your mind when you're doing the work. Are there soil gas sources that you thought were there at the steady state still plausible? Is gas monitoring actually still required? And do the monitoring wells you're putting in target the gas sources? We see so many sites where there's 0.5 metre of made ground and there's a monitoring well installed with a response zone below that. And again, the questions to be asked: how many rounds do you need? What are the groundwater depths? And obviously we need to see monitoring that takes taken and bores long enough for the gas to be stabilised and get realistic readings. So here's another site. This is the Greenfield site. There was a railway, so can you spot the gas sources? There's a little pond there, not infilled. This is what there's a railway which has been there present since the 1800s. The consultant suggested that the made ground used in its construction might be a gas risk. And on the BGS maps, there was some possible made ground marked. So clearly there was some stuff there to be looked at, mainly the made ground. The consultants did some work, but they found only clay soils. There's no made ground anywhere. And the geology of the site is pretty much London clay. So, but they still cracked on, despite the fact there was no evidence of any gas sources, low permeability pathways limited to low permeability soils. They cracked on, and they did 6 rounds of gas monitoring, which was kind of pointless really, because there wasn't a source or plausible pathway. Fortunately on that site, didn't actually find it was confirmed as CS1. Again, is this material plausible gas risk? This is made ground, typical made ground we see on many sites. Bit of brick, bit of metal, bit of concrete. There's not really much that's going to degrade in there or generate much gas. So again, if you're finding that on your site, do you really need to go any further? And monitoring well design, always important. This is another genuine site I was looking at back in the autumn. A little bit of made ground. This is out in East Anglia on tidal flat deposits, low lying on the fens. And this is where there was an infill pond, and this is where they installed all the wells. And they even got an infill ditch. So all the wells were installed in the natural soils, and all wells were flooded. And the results from that were due to the piston effect and the in the boreholes, they found some elevated flows, they found some elevated methane, and we ended up CS3 site, when in reality, if a better risk assessment, it probably would have been CS1. And then we do some bunch of NUSI, and you've got some gas monitoring data. You've got data. The 6.2% CO2. Does that really represent a plausible risk? But we tend to find that once we've got data, once we've got a number, it doesn't matter what the conceptual site model said. It doesn't matter if there was a source or not. We've got a number, and if that number is a bit higher than another number, then that site could well be classified as CS2 completely unnecessarily. So yeah, so exactly. So we see the risk assessment focus is just on data and GSVs. It's not about the conceptual understanding of the site. We still see use of data flooded wells, and we don't see much as what we say, referring back to the CSM, we're finding this CSM, multiple lines of evidence, not just gas data, but all the geology, everything else, with all that information you've collected as part of the conceptual site model. And consideration of high-risk sites. VOCs, I see a lot of sites, well, I see a lot of sites of VOCs where the principal risk driver seems to be the fact they've got 6.2% CO2 in the ground, and not the fact they've got vinyl chloride in the groundwater. And the proposals are just we'll do CST protection measures, but just stick in a VOC membrane. And obviously coal mining is another high-risk site. And the problem we get is obviously when there's all this focus on the low-risk sites, when you see a high-risk site, it just doesn't get the attention it deserves. So coal mine risk gas risk assessment. There you go. There's a picture of the flow chart from the Clare guidance. It's excellent. I'm not going to talk too much about this because Amy's already covered it in loads of detail already. But basically, what's on a coal mine gas risk assessment site with the shallow workings or deep any coal workings, we would expect this to be followed. But this is what we normally get. We'd love to get some of those nice cross section that Amy had in her presentation, but we often just get a one-liner source pathway receptor, and not really. It's just nice and cut and pastable from a previous report. So my observations are from that we've seen so far. We ask for coal mine gas risk assessments at NHBC when there's concerns, but there seems to be very little awareness of amongst the consultants working in the coal mining areas. We often just see far more like to see gas monitoring as taking due to an off-site infill pond than for shallow coal workings. And again, some focus is still on most of the time, not all the time, but most of the time, on the gas risk assessment from BS 8485. That reliance on the monitoring, 6 rounds of monitoring in shallow boreholes. And no consideration of the conceptual site model and the mining risks and the presence of shafts. So anyway, so that's where we are with risk assessments. We say a lot of over precautionary stuff, but it tends to be it does mean when you get the high risk sites, they often get ignored and don't get the attention they deserve. So gas protection design then is the next step, again, which is Neil and John have already spoken about at Corbridge. The design and detail of gas protection must comprise more than just adding at the points of BS 8485 for screening systems and providing standard details for gas membrane installations, and clearly even more so when you're worrying about coal mining measures. But this is what we see all the time. When we get a submission for gas protection design, we get a standard detail. And ultimately the question is, on these sites, who is the designer? The standard detail is fine, and if you build that, and it's absolutely fine. But what happens on site? And it's not just the membrane; it's the ventilation, the air bricks locations, and what about final? Big problem we see is on what happens outside on the site and the rest of the site. How do these designs tie in with the other designs? And as Neil's mentioned about the building safety regs, there's legal requirements on designers now. And one of the requirements is that designs should consider the implications of their designs on the other aspects of the build. And so this is what we see. So this is what we'd like to see. A standard bit, nice installed air brick. But what we often see is this: we get air bricks below ground level, which clearly doesn't comply with the drawings, not standard drawing detail where it says 150 mil above the above ground level. And what's happened here is it's not, when they were built, those air bricks were above ground level, but they've due to other aspects of the build, like level access and including ramped access to to the properties, the builders built up the levels, so you end up with below ground air bricks, which are obviously no good. And this second one was again another air brick. They scraped away the gravel fill so you can see the air brick, but that's not going to do the job. It's not as it was designed to be. It's going to get clogged. It's going to get and ultimately on a high risk site when the ventilation is important, that could be a massive issue. So what do we see? So what we want to see and what we rarely see is a detailed design report for the gas protection measures. That's it, not just standard details. This is recommended in BS 8485, so it's not a new thing. There's a lot of detail about it in NF94, and there should be site-specific, include all the key assumptions and justifications. And when we talk about site-specific, we mean all the aspects of it. Again, how are the final levels going to impact on those designs? That gas protection measure is still going to work. And ultimately, the designers, as Neil has already said, should have sufficient knowledge, experience of ground gas risks and construction methods and materials. Again, just on the specification of materials, again, this should be designed. The various elements and materials should be specified by the gas protection designer. It is not up to the architect, the structural engineer, nor the installers or the material suppliers. It should be the person designing it, and this should all be included in the design report. And verification. The purpose of verification is to provide confidence that the gas protection measures have been installed in accordance with the design and to an acceptable standard. What we see a lot of is verification membranes, and it's very clear in the industry that installation membranes and verification is getting better, and the standard of installation we see is massively improved. However, it's not the only thing we want to see. It should be confirming that the design has been built as it was designed. So what about the cross venting in the subfloor void? Are the air bricks in the right place? Are they attached? It's very easy to take these photos. This is a photo I took a few weeks ago on site, and it's quite easy when you've got a photo like that. You can see, and you can compare it to a plan quite nice and easily. But again, when we get the verification reports, we tend to see just membranes. And again, on this site, what's missing? There should be an air brick. You can't. On the right-hand side photo, you can see an air brick but then there should be one somewhere around where that partition wall is, but it's been missed out due to the inter-service coming in and the party wall. So again, the question is that change on site might be okay, but has it been okay by the designer? Is that part of the design? It needs someone to go and check. So yeah, what we see is the focus on membranes, and we get a bit of lip service to the other protection measure. We might get a photo of an air brick, but again, we don't really get the confirmation that the air bricks are where they were meant to be. And we do know that things on site change, but again, if it has changed and builder designs or something's happened, then the changes need to be evidenced. There needs to be some sort of a chain of custody that those changes have been checked and approved and agreed, and the site still provides the required level of protection. And the other thing we rarely see is a verification plan. We often see installers' plans telling us how often they're going to install, but what we want to see is a verification plan, which should be prepared at the design stage, and it should be prepared by the designer. And it should include all the elements of the gas protection system. And the designer is the person best placed to do that, because they're the ones who understand the system and where the weak points are and what the concerns should be and what needs to be checked. And again, I've already said about that. And we would ideally, we want to see photos in the membrane and subfloor void for all plots. We might need to see the independent verify on some, but we just need some evidence that things have gone in on all plots, and it should ideally be part of the builder's sort of CQA procedures. So quick summary. So I've just belted through that in about 20 minutes. I'm still on time, which is amazing. So we want to see on gas risk assessments, realistic, credible contaminant linkages to be considered only, appropriate design of site investigation, gas monitoring wells and monitoring program, and a bit of thought going into that and understanding and just an iterative process and risk assessments in accordance with BS 8485 where appropriate, or for the coal mining side of things, could perhaps for a risk assessment for coal mining gas emissions. And multiple lines of evidence, not just gas data. And ultimately definitely consider the future development in the earthworks and what's going to happen to the site. And on the design specification verification, we want to see detailed design reports from the designer, site-specific construction drawings, not standard details, and a verification plan. And ultimately, we want to avoid unnecessary installation gas protection measures, but where they are required, and coal mine gas risk assessments are a good example of sites where they really are required in a number of cases, the measures should be designed, installed, and verified correctly. And that's all from me. Thank you very much.
Thanks, Matt. Obviously, it's apparent that you've got quite a lot of the same frustrations that we have in local authority about what you'd like to see and what you do actually see. So yeah, there's a lot of comparables there. That's great. Thanks, Matt. Moving on, our final presentation today is titled Coal Mine Gas Risk Screening Tool, and it's by Darren Beriro, the Principal Geoscientist at the British Geological Survey, and Aliyssa Glen, the Principal Consultant at WSP. Darren is an interdisciplinary geoscientist with a passion for risk-based land management of land contamination. Darren is the current chair of the National Brownfield Forum. In his role at BGS, he has worked with a wide range of external organisations, including landowners, developers, consultants and regulators, to increase the impact of geoscience in brownfield land redevelopment projects. Aliyssa is a chartered environmentalist with over 9 years' experience working as land contaminated land consultant. She has particular interest and experience of complex ground and mine gas risk assessments. So Darren and Aliyssa, over to you. Thank you.
Great. Well, yeah, thank you for the invitation to present today. We've been saved a lot of background by everybody's wonderful presentations, so that'll speed us up a little bit, hopefully, and I'll just dive right in now because of that. So, yeah, we've developed a coal mine gas risk screening tool for North Lanarkshire, where there is a heavily industrialised legacy, including significant coal mining legacy, with over 95% of that council area lying within a coal mining reporting area, and over 35% of it recorded as underlain by shallow and probable mine workings. There are over 4,500 known recorded mine entries as well, and no doubt lots more as yet unrecorded. So there's lots of potential high gas risk scenarios. And as part of their statutory duties, NLC has investigated the gas risks across the area for several years, but risks have in large part remained relatively unconstrained in some of these high gassing areas, in large part due to ground investigations not providing sufficient reliable information to quantify those risks. They've also done some data reviews to potentially try and quantify some of those risks, but they were ultimately unsuccessful for the same reason. All the third-party data was designed for different designs, different reasons, and yeah, data just wasn't detailed enough to verify required. But back in 2020, we've heard already that the mine gas risk assessment guidance was issued. Since then, NLC have experienced a significant lack of understanding of its requirements from applicants under the planning and building warrants processes, and this continues to lead to delays under both of those processes as well. So NLC identified the need for a clear, consistent and reproducible approach when consulting on mine gas risks for development sites, and to this end, WSP and the BGS were engaged to develop a tool to support this. So Darren, if I can get you to change to our next slide. Great. Yes, I won't go into a lot of detail about the guidance because we've heard lots about it already, so thank you all for that. But the tool is underpinned by this clear guidance, and it's specifically the flowchart, which we've seen already, which is figure 13.1 in the clear guidance that underpins the tool, and it's used to provide an initial instant risk rating for any given site in North Lanarkshire. There are lots of different factors affecting the risk ratings, which we've heard of in summary before, but just to recap, that's including recorded mine workings and their depths, the locations of mine entries with respect to a site, how far away they are, major faults, groundwater levels, and characteristics about the superficial deposits, so things like their thickness and permeability as well. And the guidance stipulates that if through this flowchart process you find yourself coming out answering the yes/no questions as a moderate or a high risk zone, that you require a detailed mine gas risk assessment to be delivered. So our tool essentially just replicates this first initial flowchart approach. Can I get you to change? Thank you. So as I said already, the tool has been designed essentially to allow NLC to identify when a mine gas risk assessment is required for a site, and it's going to help them stipulate that as part of a planning requirement under their conditions, and it's going to enable them to provide clear and consistent advice on the requirements of mine gas risk assessments for any given site across the area as well. And the aim is that this will speed up decision-making processes and reduce delays. But it is important to note that the tool is not designed as a substitute for initial mine gas screening, which has to be carried out anyway. And that's essentially because there might be lots of site-specific data available that contradicts the risk rating that wasn't available to us in the creation or the development of the tool. For instance, third-party borehole records might not support the anticipated ground model, or if it's known that deep drainage is required or deep foundations are required as part of the development in advance, that might also contradict the screen based on what the model kicks out. So now I'm just going to hand over to Darren to discuss how the tool was actually developed.
Thanks, Aliyssa. Yes, we took a quite traditional software development approach to developing the tool. The tool is a web-based GIS that you can access using a URL, and you can interact with it within the organisation, within North Lanarkshire Council, in addition to various partners that are working with North Lanarkshire Council. So we started off with some user research. We asked people at the council, different departments, pollution control, planners, building standards officers, consultants and others, what the challenges were in terms of being able to conduct systematic, transparent, repeatable coal mine gas risk assessments. And we use that to build up a kind of picture of the users of the tool and the workflows that they would anticipate in order to grab some of the benefits from the development of the tool. And then we looked at the methods that we needed to create an output that would be useful. So we are obviously underpinning the tool on the basis of the Clare mine gas risk screening methodology that we've heard about today. We looked at the different technologies we could use, and we plumped for Esri. We used Arc Pro, we used Experience Builder, we used Story Maps. So that particular sort of company has a number of off-the-shelf products that were easy to mobilize and combine together. But equally, it could have been prepared using different technologies. We collected relevant data and we processed that in accordance with the methodology that we designed, and then we developed the tool in Experience Builder and presented that to North Lanarkshire Council and their partners in order to test and check that it actually met the requirements of the users. So the purpose of the tool was to provide a repeatable output, to standardize advice, and to help with transparency and help with negotiations between the council and generally the applicants that were submitting planning applications for housing in North Lanarkshire Council. It's designed to help North Lanarkshire Council conduct their statutory duties under the planning system and building standards system, in particular to support the pollution control team, but also help the planning team with strategic planning, the creation of local plans, and the sort of planning of longer term infrastructure and housing, and then to help building standards with building warrant approvals. We wanted the tool to be accessible to contractors working for North Lanarkshire Council, so that included WSP and other consultants. WSP provide a peer review service for consultant reports that are submitted as part of the planning system, so they work very, very closely with the officers. So developing something that wasn't accessible unilaterally wasn't really an option. And then we needed to have the flexibility to be able to add access to other contractors for the council as and when that was deemed necessary. So North Lanarkshire Council are the principal users, so they have full access to the web-based tool and the associated documentation. And then there are downstream users that we had to sort of account for as well. And the downstream users were those people and organisations receiving advice and guidance from the council on the basis of the tool. And they at the moment are going to. Well, they are receiving mapped flat images and supporting information on the risk factors, although we're hoping in the longer term we'll be able to provide full outputs, the constraint being mainly data licensing conditions. So the tool is underpinned by a number of different data sets, those from the Mining Remediation Authority, note the typo, and they include data sets like the coal mine reporting area, mine entries, shallow workings, probable workings, and then data from British Geological Survey, including depth to groundwater, geological faults, permeability of superficial geology and thickness of superficial geology, borehole records, and you might be able to link those to some of the factors that Amy was talking about earlier on in terms of superficial thickness and permeability of superficial thickness and preferential pathways. I was really impressed by Anthony earlier on saying he wasn't aware of the CLARE guidance, and I think that's great. That really sort of shows the forum that we're in at the moment in terms of just being open and honest about things in order to be able to learn. One other thing that people may not be aware of is that the Mining Remediation Authority offer all of their the data sets that you can see on the coal mine viewer that they publish at zero cost for statutory duties for local authorities and public sector bodies. So you can actually bring those data sets into your organisation now. So we did that for North Lanarkshire Council, and they didn't have to pay a licence fee. Unfortunately, BGS, with BGS, you still do have to pay a licence fee for the commercial data sets, but the Mining Remediation Authority have a zero cost public sector licence. So it's well worth looking at if you're not aware of that. So how did we synthesize all this data together in order to be able to produce risk zones and outputs that would be useful? We looked at the flow chart in the CLARE mine gas guidance document, and then for each of the risk zones, we determined a series of rules and the data sets that were required to help answer the question that the rule was posing. And then we created a logic statement to show to bring those different rules and data sets together in order to determine whether a site was in one of the 5 different risk zone areas: high, moderate, low, negligible, and no risk. We thought we did a good job, but we're really grateful for peer review work that RSK and EPG provided. We really wanted additional support in addition to BGS's and WSP's input in those GIS rule sets in order to give us the confidence that we'd interpreted the guidance correctly, and then we could move on with the development of the tool in a bit more in detail. I've mentioned already that we use the Esri software suite. So the tool is hosted in North Lanarkshire Council's ArcGIS online area, and they set up a collaboration group that allows us to work with them and to sort of control a particular area in the development of the tool and host everything that is required in their own area. And that's quite novel. It might not sound very interesting, but it's quite novel for BGS to do that. The platform, the Esri platform, allows pretty easy to use and intuitive no-code web applications. So you can bring data in from desktop GIS and you can bring it all together, and then you can host it in an interface with a number of widgets that allow you to query different aspects of your data. And you'll see how that's come together in just a minute. But it's also a secure area where you can upload data within your organization and you can share externally as required. But it also provides, I guess, not in any way the sort of same suite of tools that you would have in a desktop GIS, but enough to be able to conduct geoprocessing if that's required. So I thought it was worth just providing a little bit of background on that. So what did we actually produce then? The meaty bit. The tool and the documentation includes an ArcGIS online area hosted by North Lanarkshire Council that different people have access to, an experience builder application, which is essentially the interface, a story map user guide that can be accessed via a URL, and that's sort of an attractive way of presenting technical information along with map views of the tool, a data catalogue highlighting the data sets that have been used, the assumptions, how those data have been used and combined, and the associated license conditions. And then we created a risk zone advisory to help with the council's interpretation of the different risk zones and help with that communication onwards to internally and sort of externally to the downstream users. Aliyssa is now going to give you a quick sort of talk through of a recorded sort of screen grab that we've produced on some of the key functions. So if you're ready for that, Aliyssa, I'll press play.
Yep, go for it. Okay, yeah, so you'll see now this is the tool actually live, and basically when we start using it, we're able to select various features if you hit the My Sites features, you can start drawing. So if you zoom to an area of interest, you will then be able to manually draw a polygon encompassing whatever site shape you require. Once that's done, you're able to name it and save it as an output and go back in and interrogate the data at a later time, should you wish. Once it's saved, you can click on the feature, which you'll see right now. It sort of highlights a different color. And once you've selected it, you can run some queries in the tool. And then you'll see this output which pops up, and it's essentially all of the data broken down into risk ratings on a 50-meter grid square basis. Red is obviously high risk, orange is moderate, yellow is low, and negligible is green. No risk is graded in grey, but isn't showing up for this site because there is no risk area. And then once you click on each individual cell, you can get a breakdown of the sort of factors that are driving the risk ratings in a table format for each individual cell. So that will be things like the depth to the workings, the presence or absence of a mine entry. And in order to understand the data a bit more clearly, you're able to click on some different layers over at the left of the screen, which is what's happening right now, and make the input data sets viewable. So right now you're seeing the extent of recorded workings and the presence of mine entries, which are the little crosses on the tool. And it just helps people synthesize the information and interrogate the reasons behind the ratings a bit more clearly, because quite obviously the wider context is sometimes key rather than just looking at an individual cell basis. So that's going to help people provide more understood guidance and advice as well. So yeah, that was the little run through of that. So Darren, I guess you can skip to our next slide. I think forward one again, isn't it? There we go, great. And this is the output that NLC are actually able to share with people externally. It's essentially a spatial representation of the risk zones on the site broken down into those 50-meter grid squares. And it's able to be provided with a high-level summary of the risk factors driving each of those zones and advice. So for this site, because it has some red squares, which are high risk, it would be assigned a precautionary risk rating of high. And the summary of the risk zone factors driving that high risk for this site are the presence of mine entries and also probable workings as well. And therefore, a DQRA is required for mine gas risks. We'd then be able to describe what the minimal request for further information is, and that is essentially in line with all the risk zone advisory text that we've created and linked in the tool as well. So I won't go through that in detail, but that would be the same for any site that had a high risk output, and that's where the repeatable advice comes in as well. So Darren, I'll get you to switch to our next slide again. Yeah, so what next? The model is live and functional just now and in use, but we hope to continue to improve the model and its outputs for NLC, as well as investigating the feasibility of expanding the tool into other geographical areas to help address similar issues and aid decision making for other stakeholders, because this is probably an issue, as we've heard, that is occurring in lots of places, this lack of understanding about what's actually required under the risk assessment process, despite the clear guidance that's already there. And ideally to develop a sustainable funding model that we can use to fit with a collaborative approach to research to enable that to actually happen. So I'll get you to go on to our last slide and just summarize, because that's our time up. We essentially hope that this tool is going to be able to allow NLC to highlight potential mine gas risks on future development sites much more clearly, and allow them to communicate the requirements of mine gas risk assessment much more clearly and consistently to various internal and external parties. And yeah, we will stop there and let you read the other take-home points at your leisure, because I think that is us with our time up.
That's great. Thanks, Darren. Thanks, Aliyssa. And